Welcome, guys. This is or is it 12.6? I don't know. I think it's 11.6 or 12.6. Either way, it's optimization. Part 1. So I think I have this as 2 or 3 parts. So today's just part 1, just figuring out what optimization is. So we can use calculus to optimize problems. And when I say optimize, that means we can use calculus to find maximums or minimums of a given function, of a given problem. So we already know how to find maxes and mins. We did that in the last 2 sections. To find a max or min, we would take the first derivative, set it equal to 0, create a sign chart, and find where the max or mins existed. That's the exact same process we're going to do here, except on actual applications, on some word problems, which everybody loves. Okay, so that's what it means. So when you see the word optimization, just know that it means you're looking for maximums or minimums. Our job is to optimize some sort of function. Okay, so with that being said, we can get started. Example 1, find the dimensions of a rectangle with an area of 200 square feet that has the minimum perimeter. Okay, so a diagram helps. So let me draw a rectangle. Okay, so my rectangle is going to have a width of x and a length of y. Okay, so from the problem it says that the area of a rectangle, of our rectangle, is 200 square feet, and we want to have the minimum perimeter. So here are the key words. Minimum perimeter. This means we need to minimize the perimeter of this given rectangle. Well, the first thing we should know is, what is the formula for the perimeter of a rectangle? And if you remember, the perimeter of a rectangle is given by P equals 2x plus 2y. Or if you're keeping it in terms of L and W, that's fine as well, because P could equal 2 times length plus 2 times width. But since I already labeled it X and Y, just roll with X and Y. Okay, and then the other part of the problem says we have an area of 200 square feet, right? So I'm not going to plug any numbers in yet. I'm just going to write the formula for the area of a rectangle. And if you remember that, area is length times width, or in our terms, x times y. So there's perimeter and there's area. Now remember, our goal here is to minimize the perimeter function. We need to minimize this. And when I say minimize, or when I say maximize, I mean optimize. So remember, we're looking for a maximum or minimum, and here, since we're minimizing, we're looking for a min, which means to find a minimum or a maximum, you take the derivative, you set it equal to 0, and you solve for x. So that means that we have to take the derivative of the perimeter formula. But we can't take the derivative just yet, because if I take the derivative now, we're going to run into an implicit derivative. Only because of this y value here, we run into an implicit derivative. I'll show you what I mean, right? Let's say we decided to take the derivative of the perimeter equation with respect to x. This means that this would become p prime, which is good, equal to 2 plus 2y prime. Well, we don't need a y prime. Y prime means that the length or the width of the rectangle is changing. We're not changing anything, right? So this is why we can't take the derivative just yet. So in order to avoid a y prime, something we don't need, we have to make a substitution. So this means that we have to make a substitution for y, right? This needs to have a substitution. Okay, so this is going to be our first step. We're going to say, step 1, make a substitution for y. Make a substitution for y. Okay, well, in order to do that, we use the only piece of information given, that our area is 200 square feet. So down below, I'll bring back the area equation. A equals x times y. And from the information above, area is 200. Now our job is to replace that y value in the perimeter formula. So this means that I must rearrange this equation and solve for y. All right, we're going to solve for y on this one. Solve for y. Hey, that's solve for y. That means, fair enough, easy enough, you just divide this by x. And we get 200 over x equals y. This is our substitution. This is the sub, which means all of this substitution, all of it, is going in for this y value right there. That's what we're doing, okay? I'm actually writing big for once. So, step 2, plug in y. Plug in y to perimeter. Okay, so this means if we plug that in, you'll get p equals 2x plus 2 times our new y value of 200 over x. Simplify that, and you get p equals 2x plus 400 over x, which means this equation is now all in terms of x, which means we can take the derivative now. But before we take the derivative, rewrite it one more time. Rewrite it as p equals 2x plus 400x to the negative 1. All we did was take that x and flip it up. Okay. And now I'm going to write small. I can get rid of that. We did step 1. We did step 2. Now come over here and say step 3. We're going to call this optimize. This is step 3. Optimize. That means take the derivative, right? Take the derivative. So if we are given p equals 2x plus 400x to the negative 1, this means that p prime is 2 minus 400 My goodness. 400x to the negative 2. Then, after you take the derivative, you set it equal to 0, which means you get 2 minus 400 x to the negative 2 equal to 0, and we solve for x. So I'll take 400x to the negative 2, add it to the right. 2 equals 400. And at the same time, I'm going to take that x and flip it to the denominator. I get 400 over x squared. And then I'm going to multiply both sides by x squared. So you remember this old school technique called cross multiplying? Well, if I put this 2 over 1 and I say cross cross, you'll get 2x squared equal to 400. Okay, next is divide by 2. Divide 2, divide 2. X squared equals 200. Then square root, and I get second square root 200. I get x equals plus or minus 10 square root 2, which is also 14.14, which is probably what we want. Okay, and since we are talking about length, can length be negative? No, so we only take the plus. So this means we get our first dimension. We get that x is going to equal 14.14 feet. Okay, perfect. I'm going to have to write that smaller, definitely. Because step 4 is solve for y. So let me make some room here really fast. Okay. Let me get rid of all of this. Plug y into perimeter. Okay. I'll make this smaller. Then you'll have, you can just redo all of this. Go. Zoom in, zoom in, zoom in. So P equal 2x plus 2 times 200 over x, which gave you P equal 2x plus 400x to the negative 1. Hey, look at that. Saved on room. Now we can go to step 3, which I can fit right here. It's not step 3, step 4. Step 4, find y. Find y when x is 14.14. Okay, well, it just so happens that it's really easy to find y. We already made an equation for y. So step 4 uses this equation over here. So if I come back to this, y equals 200 over x. So it means if I come here, y equals 200 over x. And guess what number you plug in for x? 200 over 14.14, and that should still give me 14.14. So this means y is 14.14 feet as well. All right, the last thing it says is state the dimensions. So we can make that a step 5. I can say 5 dimensions. And in order for us to minimize the perimeter, the lengths of x and y need to be 14.14 feet by 14.14 feet. That's it. So in reality, we change a rectangle into a square. And the non-mathematical reasoning behind that is because nobody likes rectangles. Nobody likes to hang out in a rectangle. Squares is where people hang out. Our classroom at home was at home. Our classroom at school was a square. My room I'm in is a square. In high school, you couldn't hang out in hallways because they were rectangles. Think about it. All right. So example 2, let's do it again. So the way this works for most of them is yes, we will have to make a substitution. Okay. So again, find the dimensions of a rectangle with a perimeter of 148 feet that has the maximum area. So our job here is to maximize area. All right. So again, I'll draw my rectangle. Here's x, here's y. I'll introduce my only 2 formulas for the rectangle. Perimeter, 2x plus 2y. Area equals x times y. And remember, our goal now is to maximize the area. So before we take the derivative, we again need to substitute for that y value. So that's our first step on this. We need to replace the y value. So step 1. Maybe I'll write small this time, who knows? Step 1. It's the end of the week. The computer knows it's the end of the week too. Step 1. Make a substitution for y. And we do that with the information above. Right there, if I move me, there you go. We are given that the rectangle has a perimeter of 148 feet. So this means that we take 148 and set it equal to the perimeter formula. And once again, we will solve for y. Which means take 2x, subtract it to the left. 148 minus 2x equals 2y. Then divide by 2, divide by 2, divide by 2. And you get 74 minus x equals y. There it is. There's our sub. And once again, you're going to take this sub and plug it in for that y value in the area equation. So that's our next step. 2. Plug y into area. So I'll write that here. Area is x times y. And now area is x times our new y value of 74 minus x. Okay. Now clean this up. And area is 74x minus x squared. All right, looking good. Lots of room there, which means we can move on to step 3. Optimize. Which means take the derivative, a prime, which will give me 74 minus 2x. After you take the derivative, you set it equal to 0. 74 minus 2x equal to 0. I'll move the 2x over. Then divide by 2. And x equals 37 feet. There we go. Which brings us to step 4. I'll come over here. Four is find y when x is 37. And again, we made an equation for y. It's right there, 74 minus x. So y equals 74 minus x, which means y equals 74 minus 37, which means y is also 37 feet. Y is also 37 feet. Okay. And 5 wants dimensions. So in order to maximize our area, we must be 37 feet by 37 feet. There you go. Or if you just wanted to know that area, you would do 37 times 37. And the area that we want would be 1,369 square feet, just in case it asks. Okay, there you go. There you go. That works. Okay, cool. The second one was definitely less messier than the first one. All right. Last one on part one. Example 3. This is maximizing revenue, and we're going to maximize profit. So this has 2 parts. An office supply company sells X permanent markers per year. The yearly price demand equation for these markers is P equals 10 minus 0.001X. The total annual cost of manufacturing X permanent markers for the office supply company, C of X equals 5,000 plus 2X. A, what price should a company charge for the markers, and how many markers should be produced to maximize the yearly revenue? What is the maximum yearly revenue? All right, so this means that we are going to have to find a revenue function first, because let's see, we want to maximize the revenue. So that's where we're going to start. Okay, so step 1, find the revenue function. So find, let's just say revenue. Remember, revenue is given by R of X equals X times P, which, where we given an equation for P above. That answer is yes. It says right here in the problem, P is 10 minus 0.001X. So P 10 minus 0.001X. 10 minus 0.001X. Make sure I get all my zeros in there, 0.001X. Okay, which then means revenue is 10x minus 0.001x squared. So there it is. We have found revenue. That's the revenue function. Okay. Which means step 2, look at these words. We want to maximize revenue. We want to maximize revenue. So that means for my step 2, we are going to optimize revenue. We're going to optimize revenue. That means take the derivative of revenue. That means you get R prime of X should be just 10 minus 0.002X. See if I got that right. So the derivative is just 10 minus 0.001 times 2, yes, 0.002x. Okay, perfect. which means after you optimize something, right? After you optimize something, you take the derivative and you set it equal to 0. Which means we take 10 minus 0.002x and set it equal to 0. All right. Which means I'll move 0.002x to the right and divide by 0.02. 10 over that, and we get 5,000 equals x. So what this means is that this value for x actually answers the very first part of A. A says, what price, actually not price, not the very first one, sorry. A says, how many markers should be produced to maximize the yearly revenue? So how many markers do we need to maximize yearly revenue? And the answer is right down below. So x equals 5,000 means that in order to maximize revenue, we need to make 5,000 markers. So there's the first, there's one of our answers. So we say 5,000 markers to maximize revenue. Okay. So now here's where the work gets a little easier. Now we can finish the rest of the questions. It says, what price should we charge for the markers? And what is the maximum revenue? Take this 5,000, plug it into the price function, and then plug it into the revenue function. And those will be our answers. Okay. So for 3, where can I write 3? I'll write it down below. 3. Plug x equals 5,000 into price, let's say into P, and R of x. So first, for P, you'll have 10 minus 0.001 times 5,000. Plug that in, and this should give us the price we should sell each marker at to get maximum revenue. So this means that each marker should be $5. So this is $5 per marker. What type of markers are they selling, huh? Okay. Then take 5,000 ugly R, ugly, 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 and plug it into the revenue function. So I'm taking this 5,000 and I'm plugging it into the revenue function above. So 10 times 5,000 minus 0.001 times 5,000 squared. And if we sell, and this kind of makes sense already, if we sell our markers at $5 a piece and we sell 5,000 of them, then our maximum revenue is going to be $25,000. And I guess one way to check your work is, well, what's 5 times 5,000? That's 25,000. Pretty neat. And this is our maximum revenue. There you go. A is done. All right. Cool. On to B. What price should the company charge for the markers, and how many markers should be produced to maximize the annual profit? What is the maximum annual profit? Annual, same as yearly. So this means we need to find our profit function. Okay. So step 1. Find the profit function. Well, remember, profit is given as P of X equals R of X minus C of X, which means that from the problem above, do we have a revenue function, R of X? That answer is yes. Revenue is right there. 10x minus 0.001x squared. So that's what's going down here. 10x minus 0.001x squared. Minus, parentheses, are we given a cost function? That answer is also yes. Cost is given in the actual beginning of the function, of the problem. Cost is 5,000 plus 2x. So that's what we're plugging in down here. 5,000 plus 2x. Okay, cool. There it is. Now simplify. Yes, I could have had parentheses around that, but then those wouldn't matter. The only parentheses that matter are on these terms on the right, because that negative has to distribute. So this means P of X equals 10x minus 0.001x squared minus 5,000 minus 2x. Clean it up. P of X equals negative 0.001x squared plus 8x minus 5,000. Here is the profit function. All of this is from the given information above. That's where we get it from. Okay. 2, optimize profit. That means take the derivative, p prime of x equals, and the derivative of our profit function should be negative 0.002x plus 8. Negative 0.002x plus 8. And after you optimize something, maximize something, minimize something, you take the derivative and set it equal to 0. Now you're probably wondering, is there a difference between maximizing or minimizing a function? No, it's the same process. It all depends on the problem. No matter if it says maximize or minimize a function, you're doing the same process. You're taking the derivative, you're setting it equal to 0, and you're solving for x. So optimizing is the exact same process, no matter if you're asked to minimize or to maximize a certain function. And 8 over 0.002, we get that x equals 4,000. 4,000 what? So again, this answers one part of the question. This means that in order to maximize profit, we need to make 4,000 markers. So 4,000 markers will maximize profit. Okay, and we're near the end. To answer the last question, take this 4,000, plug it into the profit function, and plug it into the price equation again. So take this 4,000 and plug it back into the price equation above. 10 minus 0.001x. Okay. So that's step 3. Plug x equals 4,000 into price and p of x. So for price p, it's 10 minus 0.001 times 4,000, which should give us $6. So what this means is that in order to maximize profit, we need to sell our markers now at $6 a piece. So $6 per marker. And then plug it into P of X. So I'll have P of 6. Remember, I'm plugging it into that function there. And sum it up. negative 0.001 times 6 squared, negative 0.001 times 6 squared plus 8 times 6 minus 5,000. And I broke it. Negative 0.001 times, not 6, it was 4,000. Dummy. 4,000 squared plus 8 times 4,000 minus 5,000. That's better. And we get $11,000. This is our max profit. And that's our max profit only if we sell our markers now at $6 a piece. Okay. And the reason you can't check your work on this one, like we did in the last one, we said, well, what's 6 times 4,000? That's 24,000. Only reason it doesn't work this time is because profit is made up of a cost function and a revenue function. So you would actually have to do that 24,000 minus whatever the cost of producing 4,000 markers was, and that would give you the $11,000 max profit. So that wouldn't be too hard to figure out, but you don't have to do it. That's fine. Okay, that is optimization, whoops, part 1. And done. See y'all later.